What's up, everyone? Welcome to AP Statistics. This video, we're going to be talking about box plots. You probably learned about box plots back in middle school, maybe. But in AP Stats, we use what's called modified box plots. And just to kind of give you a quick rundown, it's simply a box plot that shows outliers. Like, you probably didn't deal with outliers back in middle school, but now we are. So hopefully this is pretty simple, but we want to go into a little bit of detail because now that we know more, we can do more. Box plots are for quantitative data, not categorical data. Impossible to make a box plot with categorical data. Quantitative data only. And it's actually a cool way because box plots is a graph, but it also is a graph of using numbers that are statistics. It's kind of like a really combination of a lot that we've learned that makes it cool. All right, so first off, to make a box plot, you need what's called the 5-number summary. Now, taken together, the min, the first quartile, the median, which is actually also known as the second quartile, the third quartile, and the max, these numbers together make up what's called the 5-number summary. Basically, these 5 values break your data into quarters. So think about if I kind of think about your data in terms of a number line, we have the min all the way down here. We got the max all the way up here. We got the median, which is the second quartile, right smack dab in the middle of that, like guaranteed 50-50. And then the middle of the bottom is Q1. The middle of the top is Q3. So that creates these 25% chunks, or like quarters, right? A quarter's worth 25 cents. So this breaks me down to quarters, 25% into each quarter. So each section of data represents 25% of your data. So between these, now the only thing is that it's not even, right? Like we understand that there's an even amount of data in each quarter, but the data itself could be more or less spread out, which is why a box plot could really help us understand how our data is varying. So it's important that you understand that we have 4 quarters of our data. Each quarter contains 25%. But how those quarters are spread could be very different. And that's what a box plot helps us do. So a box plot is a great graphical representation of the data, of that 5-number summary. The box, when we talk about a box plot, the box represents the middle 50%, Q1 to Q3. Hey, that's the IQR. And we put a line where the median falls. There's a line inside of that box. And then we make lines, which people typically call whiskers, that go out to the extreme values. Now, this is important. The whiskers go to the values that are the lowest and the highest that are not outliers. If you do have an outlier, first you need to identify outliers. Use the fence method to find outliers. If you have an outlier, you have to mark it with like an asterisk, like a special mark for an outlier. And then your whisker would go to the next value that was not an outlier. All right, so here's a quick rundown of a very generic box and whisker plot. Notice that we have the box. The box is definitely showing that middle 50% from Q1 right here to Q3. That's your box, okay? Then we put a line right in where the median is. Now, it's not in the middle, right? It's not guaranteed to be in the middle, but it's wherever it is. But again, it's going to be inside that box. For sure, the median, sorry, getting really messy here. That median is inside that box. Then, before you draw whiskers, you got to find your outliers, okay? So that's where we use that formula, Q1 minus 1.5 times IQR, and Q3 plus 1.5 times IQR. Those establish your fences. Now I'm going to say this 2 times. You don't draw your fences. You don't draw your fences. I said 3 times. You don't draw your fences. Your fences are simply said, hey, do I have any outliers? Once you establish, hey, I got some outliers on the lower end, put little dots, or sometimes we'll use asterisks. I don't really care. Put something to classify that those are outliers. Your whisker goes to the next data value that was not an outlier. Your whisker does not go to the fence. I get so many kids that will draw the fence. No, the fences they're imaginary. They're just so that you can determine if you have outliers. Again, the whisker goes to the next data value that was not an outlier. Now, if you don't have any upper outliers, so for example, there's no asterisks over here, that just means that we go to our max. So the whisker will go to the max if it was not an outlier. So if there was no outliers, then you go to your max, which is your biggest value. Okay? So pretty cool that that's what these box plots are. They're very, very simple to make, very, very easy, but don't overthink it, right? Just make sure you're listening to me here. All right, what can we learn from a box plot? Well, the summary statistics and graphs, like a box plot, they can be used to justify claims about the data in context. We could make claims about shape, center, and variability, all from things that we see in a box plot. Now, we can see shape, like we could literally see the shape in a box plot, right? If you're symmetric, you'll see a nice balance between your whiskers and your box. Really nice, even balance. We'll show you some examples in a minute. When you're skewed, skew means that you're more spread to one side. If you're skewed right, you're more spread to the right. So what you'll see is you'll see a bigger box or wider boxes on the right. So this is really what I really kind of want to draw a picture right here to show you guys this. So if I have a box plot that looks like this, you have to listen to what I'm about to say. A wider area does not mean more data. A wider area means more spread out. Remember, all of the areas below Q1, between Q1 and the median, between the median and Q3, and above Q3, all 4 of those areas represent 25% of your data. So just because an area is thinner doesn't mean it has less data. Just because an area is wider doesn't mean it has more data. All 4 areas contain the same amount of data. It's all about how that data is spread. So the wider the box, the more spread out it is. So this is what tells me that this data is skewed right, because the right side is more spread out. Again, 50% of data is below the median. So that means 50% of data is right there. And then again, 50% of data is above the median. So there's not more data above or below. It's 50-50. But when the data on the right is more spread out, boom, that's what tells me I'm skewed to the right. Skewed to the left would be the opposite, right? Where we see a more spread on the left side and not so much spread on the right side. So again, very bad drawing. In a second, I'll show you some nice drawings. But that's an example of skewed to the left. So here's some examples of this, right? So on top here, much prettier, right? Not my crappy drawing. We see skewed to the left. So the whisker and the box to the left are more spread out. Again, not more data, just more spread out. That's going to be skewed left. Symmetric is when we see a nice balance. It's not perfect balance, but our median is roughly in between the quartiles. Not exact, but close. Our whiskers are roughly the same length. That's nice and symmetric. We're skewed right. We definitely see that the right-hand side is more spread out than the left-hand side. So that's an example of skewed right. So make sure you understand that and that you can see that. Very, very simple to understand. Now, I want to continue to talk about how spread and shape all relates to center as well. They're all connected here. So when you're symmetric and very nice and balanced out, well, that means that the low values and the high values that are nice and balanced are going to even out, and you're going to get a mean that is very close to your median. The mean and the median are very close when you're symmetric. When you're skewed, those values that are really spread out to one side are going to pull the mean towards them. So when you're skewed left, we put a line where the median is, but when you're skewed left, the mean, now we don't mark the mean on a box plot, like the mean is not one of the 5 numbers, so we don't put a mark where the mean is, but you should automatically know that when you are skewed left, the mean is going to be somewhere a little bit lower than the median. When you're skewed right, because of those upper values, the mean is going to get pulled towards them and be a little bit larger. Okay? And I want to make sure I say that again in writing. When data is symmetric and balanced, the mean gets equally impacted by both the numbers to the right and to the left. So it's nice and set in the middle, right where the median is as well. When your data is unbalanced, let's say skewed to the right, the larger values to the right are going to impact the mean and way more. They're going to pull, tip the scale, you could say. They're going to pull the mean towards it and be a little bit higher. Okay? So here's another great example of a box plot. Once again, let's talk about a negative real quick. Now, these are the scores of kids' quiz results on Mrs. Sanchez's math quiz. Do I know what every kid got? No. But I do know this. 25% of kids got below a 30. Guaranteed. This is Q1. 25% of kids got below that, right? 25% of kids were above a 70, right? That's Q3. 25% of kids were in between, looks like maybe like a 63 and a 70. And then 25% of kids were from a 30 to that 63. So wider does not mean more kids. It means 25%, just like everywhere else. It just means more spread out. So pretty easy, pretty simple. This graph, little bit skewed to the left. The left side's a little bit more spread out. The median is definitely more to the right. But again, what about the median? The median is about 63, we can estimate. That means 50% of kids scored higher than 63, 50% of kids scored lower than 63. So really nice to see these. Here's another one right here. This one is showing, this is actually comparing, right? We can do back-to-back box plots. So that we asked people in North Carolina, hey, how long does it take you to get to work? We asked some people in New York, how long does it take you to get to work? And this is what we got. So notice that they're going up and down. No big deal, doesn't matter. So the median for North Carolina is about 20. The median for New York is a little bit more, maybe around 22. What about their interquartile ranges? The interquartile ranges is that distance from Q3 to Q1. So we could clearly see that New York has a wider interquartile range than North Carolina's interquartile range, a little bit smaller. North Carolina's looks to be about 30 minus 10. It looks to be about 20. That's their interquartile range. Whereas New York looks to be about 40 to maybe 15. Again, you're kind of estimating a little bit here, but 40 to 15 would be about a 25. So it's definitely a little bit wider interquartile range. Now, we do see an asterisk here. So New York definitely had an outlier. They had one person who looks like it took them maybe about 82 minutes to get to work. That's a long time. But the whisker ends at the next value. It does not go to the fence. Please, you do not graph your fences at all. So the next highest value would be 65. Now, the max is 82. I mean, the outlier counts. It was the max. The highest value is 82. The whisker goes to the next value that wasn't. Now, since North Carolina did not have any outliers, its max was that top whisker at 60. So we also noticed that North Carolina had a bigger range. Remember, range is min to max. It's your M's, your min to your max. So and outliers count when you talk about range, right? That is the max. So New York definitely has a wider range than North Carolina. Now, one thing I will say is that they're both actually slightly skewed to the right. Both of them have a little bit more spread to those upper values. So that's going to be skewed to the right. Both of them are a little bit more skewed to the right. But again, pretty easy to do, not very difficult at all. And I want to look at one more example with you guys. So you could be asked to make your own box plot. So let's look at an example here. So here was 31 values, very small, but I wanted to fit them on one line there. And I went ahead and I used your calculator to find everything I needed. So really utilize that calculator. I've showed that several times, and let me know if you want me to show you again. But use the calculator to find everything I need. Now, I found the median standard deviation, but remember, they are not needed when you make a box and whisker plot. I'm going to use them to make a couple points here in a minute. So every box and whisker plot, you really need a number line, right? You need a number line. Now let's see here. My lowest value was 10. My highest value was 99. So I'm going to go from 10 to 100, and I'm going to count by 10. So I got 10, 20, 30, 40. Sorry, this is kind of boring. But again, you got to make sure you're evenly spacing this out. Probably could be helpful if I used a rule or something. And you want to make sure that all of your data is covered for sure. So I went 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. All right, now we need to put a line at the median. The median was at 15.9, so that's going to be somewhere way down here. So right in between 10 and 20 is 15. I'm going to edge it a little bit closer to the 20 because it was 15.9. But again, you're just trying to estimate. We need a line at Q3. Whoops, sorry, I don't know why it disappeared there. We need a line at Q3, which was 30. and we need a line at Q1, which is 12. So 12 is just a little bit above 10. And that's where you make your box. And again, I'm very sorry at how crappy this is. I'm not good at drawing, especially with this notepad here thing. Sorry. Now, then you got to identify your outliers. Now, I actually did this in a previous video, and I don't want to waste time again, but I went ahead and found the outliers by doing Q1 minus 1.5 times the IQR. And I did that, and I think I got like negative 15. There were no bottom outliers. Nothing is lower than that. Then we did Q3 plus 1.5 times the IQR. And we definitely found that there were some upper outliers. So let me just do it real quick to get the math. So it was 30 plus 1.5 times the IQR is 18. That was 57. So that's where we said, listen, 68, 70, 99, definitely outliers. So I'm going to go ahead and put some asterisks there. And if you can use different colors, why not, right? So here's 99, right up below 100. 70, that's an outlier. And then 68, which is a little bit below 70, that's an outlier. Then your whisker is going to go to 52. A lot of people will put it at 57. No. Outliers, the fences, don't draw them. The next value that was not an outlier was 52. So that's where my whisker goes to. There were no lower outliers, so my bottom whisker is going to go to 10. So now I have this box plot. Sorry, it's so crappily drawn. But you can clearly see that it's skewed right. Definitely a lot more spread to the right. That upper 50%, just look at it, right? The upper 50% is so much more spread out than that bottom, I'm so bad at drawing, than this bottom 50%, right? It's not spread out at all. So definitely skewed to the right. And remember, look at the mean. Look how much higher the mean is than the median. The mean is way around here, right? Now, it's not outside the box. That would be really rare. But again, the median was down at 15.9. Because of these outliers over here, the mean is going to get pulled towards them. And no wonder the mean is definitely higher than the median because of that skewness. All right, so box and whisker plots, very, very simple. Not a whole lot going on with them, but they really provide us some awesome information. Awesome. Can't wait for the next video, right? You too, I bet.